All right. How is everyone doing? Hope you're doing wonderfully. And because of the unfortunate events of the world, we're gonna do this presentation across the globe. So I'm actually recording from my home in Estonia, and it's a quite awesome. Like I would have loved to be in person in Austin, but yeah, you just have to adapt. It's a good characteristic to be able to adapt and adjust your kind of routine. So the presentation of my or the topic of my presentation is going to be about time machine reading, and that's a pretty kind of popular term at the moment. It's very synonymous with intermittent fasting. So I am going to be covering everything related to that, like autophagy, time machine eating, NAD, and circadian rhythms, and yeah, it's pretty comprehensive, I think. So a little bit about me as well. So I'm Siim. I'm from Estonia, and the main thing that I do is just writing, speaking, and biohacking. So it's kind of a professional thing that I stumbled upon or chose to do as a profession. And the topic of circadian rhythms itself was uh, was kind of itself is a very new field of research as well. Although people have been knowing about this thing for the last century or so, it got more like attention in 2017 when these three men were awarded the Nobel Prize in Physiology or Medicine for the discoveries of mechanisms that control the circadian rhythms. And they did research in fruit flies, and they discovered that there was this specific gene or a protein called PER that regulates the circadian rhythms of these fruit flies, and it had a profound impact on their metabolism and day and night cycles. So the circadian rhythms themselves are very connected to everything that is happening inside your body, and basically there are these day and night light cycles that regulate these certain processes inside the body, like your sleep wakefulness cycles, your cognitive performance, your heart rate, your metabolic rate, core temperature, and every other like physiological behavior. And these rhythms, they're regulated by the suprachiasmatic nucleus inside your brain, which is the master clock, the master circadian clock that regulates all the smaller clocks inside the body. So by now we know that every cell, every organ has its own clock, like in the heart, the liver, muscles, kidneys, they all have their own clocks. But the master clock that governs all these smaller clocks is the suprachiasmatic nucleus in the brain, and the circadian rhythms are regulated by feeding schedules or like food intake, calories, and different substances. The light, especially sunlight, is most impactful and most important factor, and physical movement also is quite crucial. And there are also like some smaller things like body or like temperature itself, as well as magnetic fields, can also affect the circadian clocks, and in so doing also affect all the other rhythms inside the body. So when it comes to time restricted eating, then research has shown that it's somewhat distinct from a regular way of eating compared to like the standard American diet. And for example, this 2018 study found that early time restricted eating compared to eating without any restriction, eating 3 meals a day, had a profound impact on improving insulin sensitivity, improving beta cell function, lowering blood pressure, lowering oxidative stress, and just improving the overall health of the subjects. And early time restricted feeding refers to just eating the majority of the calories in the early part of the day. For example, in this study, the subjects ate from 8 a.m. until 2 p.m. and they basically started to fast in the afternoon, fasted throughout the night, and then returned to and started again. So they ate only within 6 hours, as opposed to the standard American diet or the Western general way of eating where people eat from the moment they wake up until the moment they go to bed. So even if you confine the eating window within a certain time frame, you're going to experience some distinct metabolic effects because of going into like a fasted state and kind of regulating the circadian rhythms in a different way compared to just eating throughout the entire day all the time. Another study on time-restricted feeding found that results from animal studies show that time-restricted feeding is associated with reductions in body weight, total cholesterol, and concentrations of triglycerides, glucose, insulin, interleukin 6, and tumor necrosis factor alpha, as well as improvements in insulin sensitivity. And human data also support these findings in animal studies. So yeah, it's not only applicable to animals and like lower life forms, but it's also quite studied in humans. So basically every organism and every animal, every living being has its own circadian rhythm. And like there are some differences. For example, rats are nocturnal, but whereas humans are diurnal, the general principles still remain the same, at least to a certain extent. Ramadan fasting is actually probably the most popular form of time-restricted eating or intermittent fasting, and millions of people do it every year. So research on Ramadan has found that it lowers cardiovascular risk factors or improves cardiovascular risk factors, and in so doing lowers risk of heart disease. And Ramadan itself is actually like dry fasting, not just water fasting. And it can be beneficial for lowering cholesterol, blood pressure, weight, and waist circumference. So this is just an example that there is actually quite a lot of research showing some of the benefits to this form of time-restricted eating or fasting. But it also not only is beneficial for people who want to lose weight, but it can also be beneficial for people who are doing resistance training, or if they're trying to optimize muscle growth. So this 2016 study found that the subjects that were doing resistance training combined with time-restricted eating, where they ate only over the course of 8 hours, then those subjects, they were able to still increase their lean body mass. But the difference between the control group, the difference between the group who ate regularly, was that the fasting group lost a little bit more fat. So they were still, both groups were able to build muscle and strength, but the group that did fasting lost a little bit more fat, and their inflammation was also generally lower. Another study on resistance-trained men found that the subjects who did time-restricted feeding reduced their energy intake by about 650 calories per day. And there was like a spontaneous reduction in calorie intake. So this could be one of the reasons why people lose weight, and it's probably the main reasons why people use it as a fat loss tool, is that just increases the satiety and they automatically begin to eat fewer calories. Because imagine it's pretty hard to eat like a large amount of food in one sitting or in like 2 meals if you're doing it in a confined manner, compared to eating sporadically across the entire day. You have more opportunities to eat if you don't have any time restrictions, and therefore you will also probably be ending up with a total calorie intake that is higher by the end of the day. So yeah, like for fat loss, intermittent fasting is pretty effective, and you can probably see many testimonials and many people preaching the beneficial effects of intermittent fasting for body composition. But there are also some unique effects that are beyond weight loss and beyond calories. So for example, this 2012 study in mice put these two mice on the same amount of calories, and one ate within 24 hours a day So they basically didn't ever go into a fasted state. They ate around the clock, and the other mouse ate over the course of only 8 hours. So the difference between them was quite substantial. So as you can see from this picture, the mouse who ate around the clock was significantly heavier than the one who ate only within 8 hours, and it weighed 4 times more. So yeah, it's the kind of reasons would probably have to do with the fact that the circadian rhythms are also very important in regulating metabolism and the body composition. So chances are that the obese mouse, it just experienced this disruption in circadian rhythms, and it never had the opportunity to fast. It was always eating, and that's why it became insulin resistant much faster, and it became obese and sick as a result of that. Compared to the mouse who ate within 8 hours, it was doing time restricted eating, and therefore that mouse was also able to just keep its circadian rhythms aligned, and it didn't disrupt its sleep schedule, and it maintained better health as a result of that. And that's kind of the biggest, let's say, difference between ad libitum eating and time restricted eating. So if you eat around the clock, then you never experience this amplitude in your circadian rhythms. You have low amplitude because you stay in the constantly fed state, and you never give your body rest, and you never give your body a chance to go into a fasted state where it's kind of repairing itself and give its digestion a break. But if you do time restricted eating, you eat only within a certain time period, which for the mice is during the nighttime. Mice are active during the night and they eat at night. So it maintains a higher amplitude in the circadian rhythms and a higher robustness, which will then improve their metabolic function. It will lower inflammation. It will lower blood sugar. It will lower insulin and lowers adiposity as a result of that as well. So yeah, if your circadian rhythms are misaligned and you're eating around the clock, then you have low amplitude, which will then lead to the body developing this sort of a dysfunction and sickness eventually. And another 2018 study on mice took 3 groups of mice. One was eating around the clock again, ad libitum, for 24 hours a day. And the second group ate in a more confined manner. They ate over the course of 13 hours, which is like 50-50. And the last group basically ate like once a day within 3 hours. And they found that the mice that ate once a day within 3 hours, they had better health, they had delayed onset of disease, and they also lived longer compared to the mice who were eating around the clock, or even compared to the mice that were eating over the course of 13 hours. So the shorter their eating window, the longer their life was, and the less disease they had. And one of the authors of that study, De Cabo, he concluded that increasing daily fasting times without a reduction of calories and regardless of type of diet consumed resulted in overall improvements in health and survival in male mice. Perhaps this extended daily fasting enables repair and maintenance mechanisms that would be absent in continuous exposure to food. So although the mice ate the same amount of calories, they still had different health outcomes because their fasting period was different and their eating window was different. And actually, one very recent study at the end of 2019, in December, on humans actually, or it was like a large meta-analysis or review, by DeCavo and Mark Metzen, they concluded that studies in animals and humans have shown that many of the health benefits of intermittent fasting are not simply the result of reduced free radical production or weight loss. Instead, intermittent fasting elicits evolutionarily conserved adaptive cellular responses that are integrated between and within organs in a manner that improves glucose regulation, increases stress resistance, and suppresses inflammation. So basically, there is like a unique metabolic effect that you experience from fasting and time restricted eating that you don't get from continuous exposure to food. And that's also one of the biggest reasons why I think that people should want to do some form of intermittent fasting. So it's going to give you like it's going to trigger these certain pathways and defense mechanisms inside the body that act like a small beneficial stressor. So it's called the Hormesis principle. Something that is small but is damaging and lethal, it's in a small amount is actually beneficial because it strengthens the body. And that's the way fasting and time restricted eating also works. And one of those defense processes or mechanisms is autophagy. And that's like a pretty popular term at the moment. And a lot of research actually shows that one of the reasons why calorie restriction has been shown to extend lifespan in virtually all species has to do with the process of autophagy. So if you block autophagy and you are still eating fewer calories, then studies in mice show that they don't live longer, even if they are under calorie restriction, whereas they have autophagy activated, then they will live longer. So in a way, calorie restriction works a lot. Calorie restriction works greatly because of autophagy and because of these defense processes that we just mentioned, that the body starts to repair itself and eliminate these inflammatory particles. And that's kind of one of the reasons why calorie restriction promotes longevity. Of course, there are some other reasons, but autophagy appears to be like one of the crucial ones. So what are some of the other benefits of autophagy? For example, it reduces inflammation, strengthens the immune system. It's involved in eliminating certain pathogens and viruses and bacteria. It has anti-aging and longevity benefits, helps the body to heal, reduce inflammation, and generally the main idea that autophagy recycles these old and weak cellular debris and this material that just begins to accumulate there. So it's like taking out the trash in a good way. So if you were to compare the standard way of eating, where you eat over the course of 12 hours or even 16 hours, where you eat 3 times a day with snacks, etc., then you rarely give your body a chance to go into a deeper state of autophagy. And because you're spiking your blood sugar, you're spiking your insulin all the time, every time you eat, and that automatically basically suppresses autophagy, because autophagy is regulated by nutrient intake and specifically like protein and carbohydrates. So if you eat, you're going to raise insulin, and that's going to stop autophagy because the body perceives there is no need to recycle things. It gets access to nutrients, and it will only start autophagy whenever it runs out of those nutrients. It only experiences autophagy when you're either fasting, when you're exercising, or when you're like mimicking some aspects of fasting with a low carb ketogenic diet. So that's the only time where you would experience this higher degree of self recycling. So that's why, like, for example, on this picture, I compared the 3 meals a day with 1 meal a day, then the difference is quite substantial. So, on a 12-hour eating window, you're never really going into autophagy. But if you do it only once a day, or even like twice a day, 2 meals a day, then you will kind of extend the period where your body experiences autophagy and where it takes out the trash, so to say, if you skip like 1 meal. And research on the average Westerner or the average American has found that most people eat over the course of 15 and up to 16 hours a day. So that means they basically start eating immediately after waking up, and they stop eating right before going to bed. So they sleep maybe like 7 to 8 hours, but virtually they're all waking time. They're in a fed state that they just ate something and they're constantly snacking. So this basically means that they're never really experiencing autophagy, because, you know, fasting for only 7 hours when you're sleeping is not enough, like, to actually go into a deeper state of autophagy. You need to fast slightly longer for these processes to kick in. And like we mentioned, being in a continuously fed state, if you eat around the clock, is going to disrupt the circadian rhythms. And, we saw the pictures of these mice earlier. Circadian misalignment is also very predominant in like a lot of people, especially if they eat, all the time. And shift work itself, where people's circadian rhythms are completely out of whack, then that's associated with like cardiovascular disease, sleeping problems, insulin resistance, diabetes, hypertension, and cancers even. So yeah, it's one of the worst jobs is shift work, whatever it may entail. So yeah, like that's why the circadian rhythm disruptions, they're not, something that you would want to take for granted. And people, even if they don't have shift work, then people can still experience a lot of these circadian disruptions in their everyday life. For example, by just, staying up past midnight, looking at their smartphone right before going to bed, staying on social media, all those things, they also disrupt the circadian rhythms, and they're going to have like a negative effect on your sleep as well as overall health and longevity. So with age, your circadian rhythms are automatically going to become more dysregulated. And like we mentioned earlier in one of the studies in mice, circadian disruptions are going to result in less amplitude or a lower amplitude in the circadian rhythms. So you're going to experience more like stagnation compared to someone who is young. Then they're pretty much still healthy. They haven't messed things up that much. So their circadian rhythms show a higher amplitude, and therefore their body is also healthier and their metabolism is functioning more properly because of this high amplitude. So the amplitude essentially entails that you have, let's say, during the daytime, you have high alertness, and during the nighttime, you're going to wind down and you're going to fall asleep. But as you get older, these patterns become less distinct. Basically, they flatten out. You experience a smaller level of alertness during the daytime and a smaller level of winding down during the nighttime. So it's going to be very stagnant or like a flat line. And that itself is going to cause like problems in the metabolism and again prevent like circadian disruptions. It doesn't have the amplitude. So the amplitude is good because you're going to basically tell the body how to function properly. Fortunately, it has been shown that calorie restriction can reverse this negative trend in the rewiring of the circadian rhythms. So you can alleviate the low amplitude of circadian rhythms that happens with age with calorie restriction. And that is caused by the metabolism of NAD. And NAD is one of the most important coenzymes in the body that is involved with virtually every process, such as energy production. It's involved with the metabolism, digestion, cognition, and even like blinking, and especially the circadian rhythms. So, you can, like greatly prevent the degradation of the circadian rhythms with things that boost NAD, such as calorie restriction, such as exercise, and intermittent fasting as well. So time-restricted feeding mimics calorie restriction because it puts the body under higher energy stress for a short period of time, and it also stimulates the same pathways as calorie restriction. So you don't really have to restrict your calories to get these boost in NAD if you do intermittent fasting or time-restricted eating. So it's like a way of biohacking the process of calorie restriction without necessarily having to like starve yourself or put yourself under calorie restriction. And NAD is also something that gets decreased with age, and that's going to lead to DNA damage, telomere shortening, epigenetic alterations, stem cell exhaustion. Is going to compromise autophagy. It's going to lead to muscle loss, cognitive decline, and mitochondrial dysfunction. All those things are, the main hallmarks of aging, and they're accelerated by the depletion of NAD. And the younger you are, the more NAD you have, and the older you get, the faster you burn through your NAD. So like that's why keeping your NAD levels optimal is like pretty important. In terms of the circadian rhythms, then NAD is regulated by these proteins called sirtuins, and sirtuins can exert their effects on the circadian clocks, so they help the circadian rhythms to function properly. And like deficient sirtuins will end up causing circadian disruptions. So you produce NAD through different pathways, and you can also take some like supplements and such, but kind of the majority of your NAD is actually produced by the body itself. So it gets recycled through these enzymatic processes. And one of the key enzymes that is required for this NAD recycling is NAMPT. And NAMPT is governed by SIRT1. So it basically means that if your circadian rhythms are misaligned, then your NAMPT is not going to work properly. And that will also end up you with having less NAD because it's not being recycled. And that can cause like chronic fatigue and all these other negative health outcomes that we mentioned earlier because of the circadian disruption and lack of NAD. So in order for your body to produce its NAD in sufficient amounts, and in order to recycle that NAD, it needs circadian alignment, and it needs to be aligned with the circadian rhythms. And because it's in a funny way, if your circadian clocks are synchronized, then your body is also going to work like clockwork. Whereas if your circadian rhythms are desynchronized and out of alignment, then everything else will also begin to fall apart because of this critical step in the production or the recycling of NAD through NAMPT and sirtuins. So that's why some form of time-restricted feeding is like one of the easiest and one of the most effective ways of preventing all these things from going out of hand. So you can prevent you can boost NAD with time-restricted eating, and you can also boost sirtuins with this form of eating. And the main idea is that it's generally better for the circadian rhythms, as well as these longevity boosting pathways like autophagy and sirtuins, to have some form of confinement in your daily eating window. So instead of eating around the clock, like the mice in earlier studies where they ate for over the course of 24 hours, or even like the average American who eats over the course of 16 hours, you would want to gradually extend the overnight fast in some shape or form. So the most popular way of doing it, and I think the most effective as well as the easiest way of doing it, is the 16 and 8 intermittent fasting method, where you fast for 16 hours and you eat over the course of 8 hours. In practice, it means just skipping one meal of the day. Like you could skip breakfast, or you could skip dinner, and you eat only like twice a day or such. Or you could also eat 3 meals, but you do it in like a confined window. So the smaller eating window is where the magic happens, and that's where the unique effects of time-restricted feeding will also get manifested or take effect. Then there are also things like alternative fasting or extended fasting, where you actually fast for longer than 24 hours. You fast, for example, like 36 hours or 48 hours. They're also, let's say, they will stimulate these pathways related to longevity in a much more profound way. Like they're going to activate more autophagy. They may increase stem cell proliferation, and they will also like make you lose weight more. but they're not inherently, like, let's say, more important for the circadian rhythms. So for the circadian rhythms, you would still want to maintain like a consistent bedtime schedule. When it comes to comparing eating early in the day and eating late in the day, then that's also like pretty, let's say, controversial topic. Like, a lot of people would argue that you have to, for optimal health, that you would have to eat only in the early parts of the day and you skip dinner. So basically you would eat only like when it's daylight and the early hours of the day. And yeah, indeed, in this study, 2019, they compared again the standard 3 meals a day with early time restricted feeding, where the subjects ate from 8 a.m. until like the afternoon. So as a result, the group who ate early and they skipped dinner, then this group had a much lower fasting blood sugar, and they also had like lower inflammation again and a better autophagy profile compared to eating 3 meals a day until, basically around the clock almost. But in another 2019 study as well, which was done like a few months earlier, they didn't see this sort of a distinct difference, or they did see a distinct difference compared to the standard way of eating, but they didn't see a distinct difference between eating early versus eating late. So they took 25 subjects, they divided them into two groups. For the first week, one group ate early, basically from 8 a.m. until 2 p.m. And the second group ate in the later part of the day. So they skipped breakfast and they ate from like 12 until 8 p.m. They had the same eating window, they ate the same calories, but the only difference was that one skipped breakfast and the other group skipped dinner. Then they had a 2-week period for washout where they ate normally. So they kind of negated all the potential adaptations, and then they swapped it out. So the group who ate early the first week was now eating later, and they skipped breakfast. And the other group who ate later in the first week was now eating the early time restricted feeding pattern. And the end results showed that there was no significant difference between eating early versus eating slightly later, as long as the hours of fasting were still the same. So compared to baseline, both fasting groups saw a small reduction in their blood sugar and inflammation and insulin. And there was no like significant difference between early time restricted feeding and late time restricted feeding. So again, the most important variable is like the smaller eating window. So you could skip breakfast or you could skip dinner. It doesn't really matter. What matters is that you have like a smaller eating window and you're not spiking your insulin throughout the entire day, compared which happened when they ate at baseline. So yeah, basically it's the answers the question, like, is it better to eat dinner or is it better to eat breakfast? You just have to choose which one you prefer and which one you find more suitable and sustainable. So, and in terms of, in terms of the final outcome, there's not much difference unless you like overeat. So the calories do still matter, but as long as the calories themselves are the same or equated, there's not going to be much difference. But there are still some guidelines to keep in mind. For example, autophagy itself, which is one of the reasons why people would want to do intermittent fasting, it has its own circadian rhythm and cycle. So autophagy peaks during the early part of the sleeping period at night, and it gets lower during the daytime when you're physically active. So that kind of tells you that you still shouldn't eat like immediately before bed if your goal is to optimize autophagy, because eating before bed is going to inhibit these processes. It's going to lower autophagy, and therefore you're going to miss out on some of the benefits. And eating before bed will also interfere with melatonin. Melatonin is the sleep hormone, and it's actually much more than that. It's like a central hormone for many processes inside a body, including autophagy, including sirtuins, including the circadian rhythms itself. And yeah, it's like a powerful antioxidant as well as like epigenetic regulator. So that's why, you know, a good night's sleep requires sufficient amounts of melatonin. And if you inhibit melatonin production by eating, too close to bedtime, then you're going to have suboptimal sleep quality and suboptimal activation of these pathways. In addition to that, growth hormone also gets released during sleep. And actually, the majority of your daily growth hormone is released the early parts of the night around like 11 p.m. and midnight. So yeah, again, if you eat too close to bed, or if you eat, um, yeah, like around once it's dark outside, then it's going to inhibit growth hormone as well, because they're actually all of these three, like growth hormone, melatonin, and autophagy, they work together. They kind of need each other to function properly. So now I'm going to give you some final kind of concluding guidelines when it comes to just constructing your eating window and leveraging the benefits of time eating. So number one, first, you should wait a few hours after waking up before eating. The reason has to do with cortisol. Cortisol is the main stress hormone, and cortisol's job is to wake you up and give you energy. But the problem is that with cortisol high, you're also more predisposed to storing food as body fat and becoming insulin resistant. So that's why it's not the best idea to start to eat immediately after waking up, because cortisol peaks in the early morning around 6 a.m., 7 a.m., and it kind of starts to lower down after 9 a.m. So that's why I think it's better to wait a few hours after you wake up before you eat, as to allow the cortisol to do its job and kickstart the circadian rhythm and allow your body to kind of burn some more fat in the process, because cortisol can also have some benefits. Like cortisol mobilizes fat, and if you shut it down immediately by eating, then you're going to miss out on some of the potential for ketosis and fat burning. Next, number two, you should stop eating a few hours before bed. Like we said, melatonin is the reason, and melatonin starts to rise after sunset once darkness falls. So one of the key triggers for melatonin is darkness. And, if your circadian rhythms were to be fully optimized, then that would mean that your melatonin starts to rise, a few hours before midnight. And that's why you stop eating also like a few hours before that. And generally, I would say that optimally, you should stop eating like 3 to 4 hours before bed, but even 2 hours before bed is also fine. Just don't make it like that you finish your meal and then you go to bed like immediately after that. That's probably not the best solution. And lastly, number three, you should also stop snacking and eat less often. So, because like we said, the average person is already eating around the clock and they never actually experience any autophagy, which is also part of the reason why they may experience these negative health symptoms, like they have high blood sugar, they have hypertension, etc. They never allow the body to heal itself through autophagy and fasting. So some form of compressed eating window is the most effective and most easiest way to prevent that, as well as promote these other longevity boosting pathways that we talked about, like sirtuins and autophagy. And of course, it's going to be beneficial for the circadian rhythms. So you're preventing, or you're increasing the amplitude of your circadian rhythms by doing that. And you're also preventing the decline in NAD that happens with age, and that is going to cause the circadian disruption. You can prevent that with time eating, which is quite phenomenal and really important, I think. So in conclusion, if I were to give some sort of a blueprint for optimal meal timing, then it would look something along the lines of this. So for example, most people sleep around 6 to 8 hours. This is the period where melatonin is high, where they're recovering, and where the body is repairing itself. If you wake up around 5 to 7 a.m., which is the right time to wake up, in my opinion, because that's the time for the sun to also rise in most places of the world. So it's important to wake up with the sun, because it's going to kickstart the circadian rhythms, and it's going to align your body with the actual day and night cycles of your environment. So your body is going to be working more properly and more synchronized. But instead of eating right away after waking up, you would want to wait at least like 4 hours or so, a few hours before you eat, as to allow the cortisol to lower down and to kind of leverage some of the fasting that you get from the night. And then you break your fast maybe around like 10 or 12 a.m. And there you shift from the fasted state into the fed one. And this is where you promote things like, anabolism, muscle growth, and getting your nutrients and staying active, fueling your physical activity. And the eating window could be anywhere from 4 to 8 hours, depending on your preference. And generally, I would say that it's not the best idea for circadian rhythms to be eating any longer than 10 hours. And even like 12 hours of fasting is like a very I don't know, like a very minimal effective dose of going about it. Like ideally you would want to fast for longer than you eat, if that makes sense. You would want the daily hours of fasting to be longer than the daily hours of eating. So instead of eating over the course of 16 hours, you would actually want to fast for 16 hours and eat within 8 hours or less. And yeah, that's gonna be just beneficial because of the reasons that we talked about throughout this presentation. And lastly, once the sun has set, that's kind of the main trigger that you should also stop eating, because melatonin is slowly beginning to be increased, and the body should prepare itself for sleep. So yeah, like humans are diurnal creatures. We're supposed to be active during daytime with the sun. We're supposed to sleep at night, and we're also supposed to like eat our calories when the sun is out and not eat when it's dark outside. So yeah, that's the kind of overall conclusion of my presentation. And the kind of the main message is that instead of eating all the time, you would want to compress your daily eating window. And that's going to be very beneficial for like longevity, general metabolic health, even weight loss, and just keeping your circadian rhythms aligned. Because yeah, like I said, if the circadian rhythms are aligned, then your body is also going to work like clockwork, and it's going to have like less stress, less inflammation, and less disease. All right, thanks for listening. And these are some of the social media handles if you want to check them out. I'm Siim Lund on basically all the platforms, and my website is siimlund.com.